All right, so we're going to continue with our work from Chapter 3, Section 1 when we talk about graphing polynomials. And now we're going to look at them in standard form. So standard form, as we see here and we discussed, is where they are unfactored. So it's completely multiplied, FOILed out, anything like that. Now, when it's like this, it makes it actually really a lot easier to find our degree and our sign. So our degree here is 4, and our sign is positive, because for those, we're just looking at that leading term. Our y-intercept, since we can either plug things in, or we can see if there's a constant term. Again, that only works for polynomials. It doesn't work for other types of functions. So if we plug in 0, it becomes 0 minus 9 times 0. Also, you notice that there isn't a constant term. It would be plus 0. So these ones are easy to find. Now, the nice thing about factored form is that the roots are much harder to find. So in order to find our roots, we have to actually do the factoring. So no matter what, you're going to have to find a factored form anyway. So for roots, you have to factor. And I am going to use this space right over here to factor our polynomial x to the 4th minus 9x squared. Now I'm always going to start by looking for a greatest common factor, which in this case is x squared. And then we have x squared minus 9, which is a difference of squares. So the fully factored form is x squared times x plus 3 times x minus 3. I'm sorry if you hear some noises in the background. My dog is being a dingus and chewing on a lot of her toys. Now, if we look here, we see that we have a multiplicity of roots here that's even. So again, remember that means that at the point 0, because that's the root for this factor, it's either going to do this or it's going to do this. It's going to bounce at that point. So I can start plugging in our points, positive 3 and negative 3 as our roots based on our factored form. Now, and we have an even positive, so that means our endpoints are going to go up like so. Let's use the correct. So we're graphing. We're going to have an endpoint like this, an endpoint like this. And so it's coming down from here, and it's going to go through, since that's not the one that's a multiplicity. Now we're on this side of the x-axis, so it's going to do this, and then come back up and connect like that. And there's our sketch of x to the 4th minus 9x squared. Looking at number 2, again, the degree and the sign, we just look at this first term. This is an odd, and it's positive. So our endpoints are going to be one pointing this way, one pointing up, like so. And our y-intercept, it does have a constant here, which is negative 12, which means I want to do a little adjusting with the scale since it only goes to 10. So I'm going to call each square 4. So this would be negative 4 here, negative 8, negative 12, positive 4, positive 8, positive 12, negative would be here, negative 4, negative 8, negative 12, positive 4, positive 8, positive 12. So we have a y-intercept right here. And now here's the tricky part of finding our roots, because we're going to have to factor. Now we have 4 terms, x cubed plus 3x squared minus 4x minus 12. And remember, if you have 4 terms, you want to think about grouping. So in this case, the common term of x cubed plus 3x squared would be x squared times x plus 3. And the common factor between negative 4x and negative 12 is negative 4. And then we also get x plus 3, so that we know we have factored correctly. We have x squared minus 4 times x plus 3. Again, a difference of squares, x plus 2 times x minus 2 times x plus 3. And we end up with our roots. Positive 2 and negative 2 are here. And then 3 would be here. Oh, negative 3, I apologize. Negative 3 is right here. There's no multiplicity, so they'll all go straight through. We're going to start at our line, and we've got to go through here first, just a little dip all the way back down to 12. And then I'm just going to move that over a little bit since it didn't need to be quite so spread out. And that would be our graph of x cubed plus 3x squared minus 4x minus 12. If you have questions about graphing in standard form, again, please always leave them in the comments, nominate things in the homework form, or grab a meeting on Zoom. Look forward to hearing from you.